cheap solar power, batteries, and electric vehicles are changing the transport and energy sector as we know. I bring in guests to this podcast who will help you with their ideas to navigate this energy transition. Thank you for joining. Good morning. Good to see you after quite some time, no?
Yeah, good morning. Thank you for having me.
Thank you. Maybe I know that you have been into so many different fields when we discussed at the back of the Asia Clean Energy Forum, floating solar at that time. I see you're doing many things. Maybe you can do a introduction of what you have been up to.
Okay. Yeah, I think I'm with the ADB, with the Asian Clean Energy Forum since 2008. So that was, I think, the second or third one that the ADB did. It was very small, some 200 people that were participating. And the big thing was I won the top innovation prize in the field of renewable fuels.
Mm-hmm.
So I'm dealing in this field already almost 20 years now. Yeah. With a big interruption for floating solar, as you already mentioned. Yes. So introducing myself, by birth I'm German, but I'm more or less a cosmopolitan living all around the world. I'm a resident of Japan. I've been in this country since 1980.
Wow.
And yes, it's my second home. Actually, I've been longer in Japan than I was in Germany. So interestingly enough, my background is, by profession, I'm a lawyer and economist. I have 2 degrees. And I came to Japan on a scholarship in 1980 from the Mombushu, from the Ministry of Education. And I studied for 2.5 years at Keio University, one of the top universities in Japan, which was coincidence. The professor had my topic, so that's the reason why I ended up at Keio. But sometimes fate is good. So then after that, I slipped into business. It was the bubble economy at that time, so had a lot of opportunities. I became consultant to many Japanese companies and had very good contracts. And when the bubble burst, I had a rough time when the good living ended for a settled end. But anyway, that was for 3 years. I recoiled, went back to my home and restructured my company. And then from 2000, I started to work in renewable energy. And my first project in that field was sky sail. I don't know if you are aware of sky sail. At the moment, a lot of discussion is ongoing how to implement wind propulsion in the maritime industry. So they are using Leitner rotors and rigid sails and things like that. And Sky Sails was a pioneer in that field, a German company. Their system is now sold by Airbus. So it's developed over the time, and Airbus is, I think they don't have even a license. They do it just because it's good. Yeah, it is a kite system. So they developed this kite over time, and it has a very interesting concept. Anyway, you can find it on the internet. It's a big kite that is going up to 300, 400 meters, where the wind is very steady and very strong. And though the kite surface is not very large, it has a tremendous strength. Yeah, so that was my connection with the maritime industry that comes handy now again. And thereafter, in 2005, I got into biofuel development. I did the marketing for a company that had a technology to convert lignocellulosic biomass into diesel fuel. Lignocellulosic biomass is, for example, simplest rice straw, but also sugarcane trash, sugar bagasse. Yeah, that is lignocellulosic biomass, which is cellulose plus lignin. I did the international marketing, so I went to the Philippines and had discussions over there with Pete Maniego. You know him probably.
I know.
So he was my first contact in 2008 or so, or 2007.
But was there any project developed out of the biofuel?
Out of the biofuel, there were about 10 projects developed, but I come to that later. The problem with that technology was there is a second law of thermodynamics, which says you have to have a hot body, and from the hot body, it goes into the cold body, not the other way around all the time. Yeah, you put a pot of water on the stove.
Yeah, it's a basic thermodynamics, yes.
Yeah, and
Heat flow one direction.
Yeah, and with this system, it has a reaction temperature of 280 to 320 degrees centigrade. The problem was that at that time, at the walls, if it's heated from outside, if a reactor is heated from outside, the walls become hot, so they are 400 degrees or 450 degrees to have enough energy input. And that was a problem because the biomass was carbonizing at the walls. So that means there was settlement at the walls, and that built up an insulating layer. Efficiency dropped dramatically. And so there was a lot of thoughts about how to heat the liquid in the reactor. And that was really not so easy because you have this second law of thermodynamics. So you need always a hotter flame or whatever to heat it up to 280 to 320 degrees centigrade. The invention at that time was to use a friction pump. Friction pump has an internal friction, and if you rub your hands, it's getting warm. And with the friction pump, it was possible because it was running inside the liquid to reach the heat. So we had very good success with that. That means we were able to even produce EN 590 compatible
Now, I think
diesel.
we are getting into too technical for the audience. So I just want
Anyway,
to know, did we develop a project?
Yes. And thereafter, they built about 10 or so units. One unit in the US, in Massachusetts, with a large company, Covanta. At that time, Covanta is a waste management company, and they tried to do the non-plus alpha, the really big stuff. They wanted to have a processing of municipal solid waste. That is a holy grail in waste processing, yeah. And they wanted to use the mix of plastic and paper and cardboard, and they wanted to produce diesel. This succeeded. The problem is municipal solid waste is a mixed bag. There's everything in it, and the consistency is changing all the time. That means one day you have more garden waste, the next day you have more plastic, and so you never get the same feedstock. And even if it's pre-processed refuse-derived fuel, are you familiar with refuse-derived fuel? That is pre-sorted waste that is small, and it's used in boilers for thermal recycling. It's called thermal recycling. A terrible word. Anyway, the result of that was they gave up on it because they never got a constant result out of it due to the specifics of the feedstock. Yeah. So we today are concentrating only and exclusively on biomass. Yeah. So it's relatively easy. So that was built, but none of these plants really were successful to go into high production volumes. So the result was great, but the production volume was not. The result was so good that one day I drove a group of Chinese gentlemen from Dresden in Germany to Frankfurt Airport with a Mercedes microbus, a 9-seater, and that was running on common rail, really the high degree diesel engines, common rail injection. And that is very demanding. And that fuel came directly from the tap. So we did a test on, what was it? Wood chips and residue from wheat flour production. So that was a mix of two different feedstock types. And the result was great. We did an 8-hour test with a generator, with the Yanmar generator. That went very well. And then afterwards, we put the fuel into a 7 Series BMW. They did a couple of turns, and then we took it into the microbus, and I drove them back. It was very successful. The problem was our top guy didn't want to deal with China. He was afraid that they take it away. And anyway, it's a long story.
But what's your view? Can this technology be used with water hyacinth as a feedstock?
No, I know the water hyacinth. I have a different solution for that. I can get to that later on. This requires 5 to 10% moisture content for processing. So
okay.
if you have water hyacinths, you have just 5% or 6% solid matter in it. It's almost all water. I can discuss that with you a little bit later, but let's just continue with our thought. What happened was, because of all these problems, we shelved the project in 2013. At the end, we did a couple of tests with microwaves, and that went pretty well. So the thing is, you can have a much higher energy input with microwaves, because microwaves have the feature that they heat a body from inside out. Yeah, you know that from your microwave oven. If you had the cup is cold, but inside the liquid is hot.
It agitates the water molecule inside, yes.
Exactly. And so the result was great. And then we were looking around to find an industrial application of microwaves, and wasn't available. So at that time, there was no industrial heating of liquids available. So we shelved the project. We had a big loss. I lost $3 million of my own, which was not nice. But anyway, I switched over to floating solar and did it quite a while I'm still doing it, but on a lower engagement level, still doing it. So in 2020, I became aware that in the meantime, we had the possibility to get a large-scale microwave system. It's used in the food industry to heat pasteous material. It's used in the chemical industry. And with all my experience in the past, I thought this is the opportunity, because I saw what's happening in the maritime industry. I saw that the demand was there. And now we have the point where we can really go with a microwave system into large-scale production. So we discussed it with the manufacturer. It's a perfect situation now. That said, what are we getting? What kind of products are we getting? So the maritime industry has low demands on the fuel, as they are using heavy fuel oil and very low sulfur fuel oil, a little bit advanced oil, but it's not really an oil. It's like tar, which has to be heated up to 60 degrees centigrade to even become liquid. So the fuel is very low quality, but cheap. And that's the reason why the industry in principle would like to stay where they are. In the meantime, the customers are the guys who are noisy. And so companies like Amazon or IKEA or such kind, also the large supermarket chains and things, they are demanding low carbon fuels because they have their own agenda on defossilization. And I'm using defossilization instead of decarbonization. Yeah, I think the word decarbonization is totally off because we don't have a problem with carbon. Our body is 16% carbon. We are exhaling carbon, the CO2. Each human being exhales about 4 to 5 tons of CO2 in its lifetime. But it's not harmful because everything that we are getting into our body is coming from above Earth. So the problem is the fossil stuff. Yeah, I'm not using decarbonization anymore. I'm using defossilization. I think that's the right term to use, and it's making inroads. I see it now more and more on LinkedIn. So that's good. Anyway, from that point on, we were really going into it. And maritime industry is a large market, 300 million tons of fuel oil per annum. They are concentrating currently mainly on green hydrogen. green ammonia and green methanol. The slight problem they have is it's extremely expensive. So they have to deal with prices that are 3, 4, 5 times higher than even the better fuels in the maritime industry, which is MGO, marine gas oil, which is basically a diesel type. And so we are concentrating on bio-MGO, biological marine gas oil is our target. And as we are using lignocellulosic material, which grows above ground and taking up CO2 during its growth, and we set it free, the fuel is carbon neutral. You are, of course, familiar with that concept, carbon neutrality. But we are even a little bit better. The thing is, we can crack the lignocellulosic material very nicely. We get a good diesel out of it. But the problem is then the lignin. The lignin is a very tough material and we cannot crack it. But it comes out as tar type of material, and biobitumen can be used in road construction. The system is very attractive for the Global South to improve the infrastructure. And the biobitumen is stacking away carbon permanently. It goes into road construction, is recycled several times for about 100 years, and then goes into the landfill. So that what we are producing, and that makes the fuel, the life cycle assessment, the fuel has to be in its life cycle assessment carbon neutral to be accepted as renewable fuel. Yeah, it has to be carbon neutral. And the life cycle goes from cradle to grave now. Before it was from tank to stack, yeah. But now it's from cradle to grave, so the demands are much higher. With the result as, for example, liquid natural gas is no longer considered really beneficial anymore because all the fracking in the US is considered in the life cycle assessment, and that makes it difficult. So for us, this means because we have product in the life cycle that is sequestering carbon in solid form and stores it permanently, we are actually producing very high grade carbon credits, very high grade, because we can really prove the feedstock came from farmer Nitin Jain in Punjab. In that village, it was transported by tractor using our fuel. It was processed with a grid from our own solar and wind power. And if it's raining, we are using a generator running on our fuel. So we can prove from cradle to grave how the specific batch has been produced.
Where is the market for it and how much it's costing you now? How is the competitive pricing?
The pricing, we could, in principle, give it almost away for free, but I don't say that too loudly. But the thing is, we have 3 revenue streams with this process. 3 revenue streams. The first is the fuel. The competing fuels are the biofuels, typical biofuels from vegetable oil and animal fat and things like that. That is the first. That is priced around $1,300 to $1,400. Yeah, then you have the high grade. These fuels, biodiesel fame, they have certain downsides. So, for example, in the shipping industry, they don't mix more than 25% of the biofuel into fossil fuels. Yeah, otherwise they have mixing problems, it's demixing and things like that. So there are limitations to this fuel. So the better fuel is a hydrogenated vegetable oil. Neste, for example, in Finland.
Now, what's the price? I was asking about the price.
Yeah, the price. I'm just explaining. HVO is approximately $1,600 per ton. And we want to sell our fuel for under $1,000 per ton. So that means we want to make it attractive. We could even sell it for less because we have 3 revenue streams. Biobitumen is a product in itself. So if we sell our biobitumen, let's say in Manila, in the Philippines, a ton of bitumen, fossil bitumen is around $600 to $700. depending on the quality. And so that comes on top. So we have, let's say, from 3.5 tons of hardwood chips, we are producing 1 ton of fuel and about 800 kilogram of biobitumen.
I understand the details. You have a lot of details, but I just wanted to. So, is this at a pilot stage? You've been using future tests. So, when is the production? What's the capacity? Where are we with the technology?
So, the technology is ready. We have pilot plant in Europe that we actually want to buy at the moment. I'm working on the funding for it. It's located in the east of Europe.
What sort of funding you're looking at, and what sort of timeline are we looking at here?
Yeah, I'm looking for relatively soft funding, because if you go for really hard VCs, yeah, they want to maximize all three revenue streams. The third revenue stream are the VCUs, which are $160 to $170 per ton of CO2 sequestered. Yeah, so that is
Wow,
going on
that's a
top.
very high price. I don't know who is going to give you that.
Oh, a lot. Microsoft is paying $500 because they want to sponsor certain companies.
Okay, that's a different issue. Yeah, that's a different issue.
So we have fuel, $1,000, $700 for the biobitumen, and $160 by 1.5. On top of it, $2,000.
What sort of timeline for your pilot finish and to bring the technology to the market?
Yeah, the plant is actually there. It's already in existence because it is a plant of the first. I was lucky. I found a plant that was first generation that is still using the friction pump. So what we will do is we take out the friction pump.
But what sort of timeline?
4 months.
4 months. But have you already started?
I'm in the funding process, yes. So I'm attracting funding for it.
So by next year, you will have a pilot done.
Yes, the pilot is already there. So the process as such is proven. The matter that we have to prove is that we can mass produce this product. Yeah, that's what we have to prove. But we have the experience from the food industry and so on. So we know that we can, with the 100 kilowatt per unit, we can heat our paste that's going through it.
Sure. I'm just trying to see, because I talk to a lot of people, I hear a lot of technologies. Some are pie in the sky. This obviously seems like you have done quite a lot.
We are already marketing. We close pre-delivery contracts with shipping companies.
How large contracts?
Yeah, this plant can produce 8,000 tons of fuel oil per annum, so it's not big. And we are not going to go in larger volumes in terms of units. So we stay modular. That means one module, we can multiply, we can daisy chain.
So how large is your team in the company?
We have still relatively loose connections, but in total, our worldwide team is about 20 people.
Okay, that's pretty good. Okay, so I think when this pilot is done, maybe we can have another conversation on this one. Looks like a very exciting, but let me start a little bit more on your mature end of the activities, the floating solar, which is a well-established technology. And you mentioned earlier that your floating even can dive. Maybe you can explain a bit more.
Okay, it's floating solar. When I got into floating solar, it was very new. That was 2013, I said. In 2014, I founded the group on LinkedIn, Floating Solar, which has in the meantime 7,000 members. So it's quite substantial, and they are all specialists. Very deep discussions we are doing. Anyway, the 2013, there was just one floating solar project in Napa Valley in the US. And that was a very small project. Then Hyacinth, the French company, their first plant on an irrigation pond in Japan. So that was a very early stage. And I saw these contraptions like one float and one solar panel. And I thought this is a recipe for disaster. And in the meantime, we have seen dozens of them. The last one was the 500 megawatt solar system in China that was completely destroyed in a typhoon. So it's a logic from sailing. If you set sail, you catch the wind. So if you put a solar panel in a certain angle on water, you're catching the wind for sure. There is no way around it. And so we had the first accident here in Japan. 17 megawatt system was destroyed here on an irrigation pond. And there were, in the meantime, maybe 10 or 12 major accidents with this system. So my concept was different. We were considering to put lightweight solar modules on top of it. And in the beginning, we were doing the same stuff. We wanted to put it on our large scale floaters with conventional panels, but we came to the conclusion that's too dangerous. We shouldn't do that. In 2016, I had a very interesting meeting in Singapore, actually, and a guy from Holland. I did my little dog and pony show at that time in front of about 40 people and explained what we are doing. And I said, my dream would be to have a flexible, thin, lightweight module. And he stood up and was waving a piece of his system there. It's very interesting. It is flat. It's foil type. They can produce up to 30 meters length in one solar. It, at the moment, still carbon. It's carbon, yeah, silicone. It's silicone, but amorphous silicone. So they do multi-layering of amorphous silicone.
Yes, how it is different. We are talking about the floating platform that you had a
Yes.
different technology.
Yeah.
How is that different and how many people have used it? Because I'm sure thousands of megawatt floating solar floating around the world right now.
Right. Yeah, I made the mistake and set on this one company, and they took until recently. They start now to mass produce the product. I was told 2018, end of 2018, this product is available.
I think we are getting into too many details. Let's stay focused on the big time story because that's what the audience want to know. I know we are passionate people, get very passionate about the details, but
Yes.
I was just trying to get the bigger picture.
Yeah, I had a very good partner in India. We had a very nice project with the largest tire manufacturer in India, in Chennai. And they have industrial ponds over there, and they
Okay.
wanted to put solar on it. And we wanted, of course, to have a demonstration of our system. So they were producing already in small scale in Europe, but they were not able to deliver enough thin film systems for us. So we got stuck, still waiting for them to produce and to come up with the product. And unfortunately, at that time, my partner in India got cancer, a very nasty cancer, and he passed away in 2020.
Sorry to hear that.
So I lost basically my strong foothold in India, which is one of the main markets for floating solar. Because I got into the fuel business again, the solar became a little bit on the back burner.
What projects are you working on that is producing results right now?
No projects at the moment. So the company in Holland is now finally in the stage that they are able to mass produce. The system has multiple very large advantages, commercial advantages. For example, the installation is very simple. It's using a double-sided tape. If you ever had a carpet in your apartment, you have this double-sided tape. And 3M has developed a double-sided tape exactly for this purpose. They give 25 years of adhesion guarantee for it. So what we are doing, we have my frame. It's a 25 up to 25 by 25 meter frame.
Wow, that's a huge frame.
Yes. So that's a maximum. We want to start about 12 by 12 meter.
Extendable, or these are just like a plunk it in and connect and make a big frame? How do you ship a 25 by 25 meter frame?
No, that are modules, corrugated double-walled water pipes, you know them, the plastic. So that's what we are using. That are our floaters. So we have from the beginning already a safety factor in it because it's double-walled. So even if we have a crack in the outer wall, it will not go inside there. But it gives us also the possibility to controlled flood the inside. And then later, when the storm is over, we just push out the water with air pressure. So we can actually really make it dive. It's not a joke that I told you, we can really make it dive. And the flat plastic is immune against water. Yeah, we just have to take care that we have watertight connectors. That's all. Otherwise, we can do it underwater. It can really dive. So we have this frame of about 60 centimeter diameter double-walled pipes that is square.
That's a huge, 60 centimeter is 2 feet. That's a huge pipe.
60 centimeters is like that.
That's 2 feet.
Yeah.
So that's quite big pipe.
We have a large installation. So for the 12 by 12, we use 40 centimeters. For the 25 by 25, we use that surface. Even if it's lightweight, it still has quite some weight to carry. It has to stay above water, so it has to carry the weight of the solar modules.
No, I understand. I have a couple of engineering degrees. I understand the engineering side of it. But what's the status of this project? Have you done a pilot yet?
We have done pilots, yes.
How large is the pilot, in megawatt or kilowatt?
Not megawatt. No, that was in kilowatt. It was something like 150 kilowatt or so.
So it's on the ocean or on a lake?
It's on a lake. We don't go on the ocean. Too risky.
Yeah, quiet water. Has it started production yet?
The production is ongoing every day. So these water pipes are done every day. We use roof membranes that are used in construction. So if you have a flat roof, you want to have it watertight, you put a membrane on top of the roof. You know that. And that is what we are using as a carrier medium. So we put it on this frame, and then we roll out the 12 or 25 meter long modules. We roll it out, paste it on, and it's done. So the installation is very fast.
Yeah, these modules are what, 15 or 14% efficiency?
It's 15%. Now they have triple layer design, so they catch more than usual. The interesting part is also that these modules are performing much better in bad light conditions. So if you have overcast conditions, these modules perform pretty well, much better than conventional silicone panels.
So what about using the same thing? You have the 3M double-sided tape. Why can't you just put on the rooftop?
Yes, of course, that can be done.
Maybe a better solution. Why go into water? Because there's so many empty roofs.
Yes,
you can cut them to the right
rooftop
side.
is a great. They are putting it on oil tanks, for example. They put it also on sidewalls. So vertical installation is possible.
Yeah, also a solution for a lot of people who are driving electric car have this range anxiety. So if you can roll in 10 kilowatt charger, you can lie down, enjoy the sun when your car gets extra 5 kilowatt of juice.
Yeah, that's all possible. I'm not concentrating on that.
Because somebody did round Australia with exactly the same technologies, just to make a point. I think a couple of years back he did his Tesla.
I know, but the surface is too small to really make it a big difference.
Now you can roll it out when you're driving.
Okay.
You can roll it out. What else you do for fun? I think we're talking too much work.
Not too much fun. I'm working 10 to 12 hours per day because we can really make a change. Because if we succeed, let's say, put 100 million tons of biofuel into the shipping industry, you get 100 to 150 million tons of CO2 out of the atmosphere. So we can really, through the sequestering, we can really make a change. And I'm pretty mature, let's put it this way. I'm an old guy.
Early retirement, so I'm not very young either.
So I have to see that I get my job done. And so I'm working very hard. So what I do otherwise, I like to eat Japanese food, which is very healthy. So I like sushi, and I'm in the right place here.
And you cook?
I cook myself as well. Yeah, my wife passed away 3 years ago, so I'm handling my own stuff.
Yeah, sorry to hear that. Now, just one little question. Sorry, digressing again. You mentioned that you have a solution for water hyacinth.
Yes, we have actually done some tests with the German institute on a comparison test. There are two technologies that can be used for water hyacinths. One is called hydrothermal carbonization. Have you heard about that technology? Hydrothermal carbonization. Now, what that does, you have a big pressure vessel. You have water in the vessel, so the water in the hyacinths doesn't hurt us. Then you put the water hyacinths in it, and then you heat up the vessel to 350 degrees centigrade with a lot of pressure. And that's carbonizing the material. So to retrieve the carbon, you just filter the water and you got carbon.
So you pressurize or you
Yes.
just heat it up only?
Yeah, you heat it up and the pressure is automatically developing. Yeah. If you have 350 degrees hot water, then you have a lot of pressure. Yeah. Anyway, that is one. And the other one is thermal. It's a continuous process in a larger scale. So that is also possible. We compared these two technologies, and I have all the data here, and I still have some samples of the coal. So we can actually carbonize water hyacinths.
Because
It's
I'll
possible.
be very interested. I'm working with the government and they're looking at a solution for the Philippines. So if you have some data, and I think it's a global market across Southeast
Yes, it's a global market.
Asia
I know
region.
that. Yes, yes.
If you have something, really appreciate that. I'm sure some of our listeners are also challenged by the water hyacinth problem.
Absolutely. It's a global
Mosquitoes, right?
problem. Yeah, like mesquite is also a big problem. Ethiopia is suffering seriously, and we can convert that stuff into fuel oil. So Ethiopia can become an oil exporting country. Sounds
Well,
funny.
I'm
Yeah,
actually very interested if you could send me something in the next couple of days.
sure.
And also we'll post on the link here with the podcast so that if someone wants, they can follow it up. How can people find you? Where are you?
I'm on LinkedIn. You find me on LinkedIn. That's the best to find me. My website is still in growth. I don't have the time to really get into it. I have the people who can do it, but somebody has to make the text and everything, and that's me. And I just don't have the time. But I have a website, but it's half done, not really very attractive. So I wouldn't recommend that. So get in contact with me and I brief you directly, WhatsApp or Zoom or Teams, whatever is necessary. So not a problem to get contact
Wonderful.
with me.
Thank you so much for your time. Is there anything else you would like to share?
Yeah, the thing with the fuel that it's really to my heart is we can do a lot for the smallholder farmers. Yeah, we can create, especially in India, it's very, very close to my heart. In India, the farmers are under pressure. They are burning the paddy stubble in the fields. And every year from October to the end of December, you cannot breathe the air in New Delhi because the farmers are burning really huge amounts of feedstock. They burn it and they're under pressure from the government. They made it a crime to do it. And of course, nobody cared about it. It was very difficult to catch these people. So in the night, one match and there it's gone. But what we are doing, we purchased the feedstock from the farmers. You put a value on something, for sure somebody will collect it and do it. And that's what I see is we can, I have a potential project in Ivory Coast for the cocoa farmers there. And so we can use their waste material, their worthless waste material, and put a value on it. And so we can really make the life of these people much better than they have it now. Yeah. So that is something that we will always have. We can resolve environmental problems like the mesquite or with another technology, the water hyacinths. With that, we can make the world a little bit better place. That's very important for me.
Thank you so much for your time. Thank you so much. And I'm sure we'll bump into each other into one of those Asia Clean Energy forums again.
For sure. Maybe next year. Are you at the Asian Clean Energy Forum next year?
I'm not sure. I spend a lot of time in Sydney and sometime in Manila. So depending when and where.
Thanks for your time.
We hope you enjoyed this episode of Energypreneurs. To continue listening to this conversation, please visit us at Energypreneurs. Thank you. See you next time.